Hi, my name is George Cubb.
My name is Mike Spicola.
And we are here today to conduct a virtual Cadweld certification training session. So, a couple of longtime Cadweld guys. I've been here 47 years.
47 years also.
So, almost 100 years of experience between the two of us. I work in ERICO technical support.
I'm in engineering applications.
So there's probably nothing about exothermic welding that Michael and I haven't touched or seen or experienced. And so we're going to try to leverage some of that knowledge that we have to give it to you folks so that you too can become experts in making Cadweld exothermic connections.
Right.
So we're going to get right into the important fact of PPE and safety. So what we say is that if you're going to make Cadweld connections, you should wear safety glasses and you should have a pair of leather gloves. These are the two main and important things that we think anyone who's going to make a Cadweld connection should be wearing when they're doing that work. So there are going to be plenty of other things that are going to be required at the job site that you're working on, and the AHJ will set that forth and they will tell you what you have to do. Hard hat, steel-toed shoes, safety vests, all kinds of things that are outside of our purview, and so that is fine and dandy, and we would expect those folks to enforce those rules. For us, the main things are the plain things: leather gloves, safety glasses. So while we're on the subject of safety, when you're getting ready to do this training session, it's really important for you to think about everybody's time is valuable. Your time, the trainer's time. So making sure that you turn your cell phone off before the session starts would really be great. And if you're having part of the training session indoors and then you're going outside to do the Cadweld connections, it would be great if you could leave your cell phones in the building. We know there's a lot of important calls, but hopefully the world could wait for just a short time while you're conducting this training and receiving this training. The main thing is, while you're on your call, you could miss a very important point, either about how to make the connection or something very important to safety. The last thing we want is for you to come back to the training area and then touch something that's hot. So there you go. There's a little basic housekeeping about exothermic welding in our training session. So us senior citizens here will guide you the rest of the way through this training session. I know we don't look that old, but we are. So the very next thing we're going to talk about is something very important: mold prep. What we're going to cover now is probably one of, if not the most important aspects of making a Cadweld connection: mold prep. So Mike and I are suited up, we have our safety glasses, we have our leather gloves, and we are about to get started making our first connection. So an important point that we'd like to make to you is we are going to show you all of those steps to do pre-weld prep right now with this mold. Then as we go on to make other connections, we're going to skip that step. But for those of you that are keeping track at home, you can be assured that we have done all of the things that we're going to talk to you about with that mold in order to get it ready to make the connections. This step is very important, and if we do this right and make sure that everything is clean and dry, then it will pay dividends later on. And those dividends will be, we will make these beautiful, what we call restaurant quality Cadweld connections.
I always like to say 90% of Cadwelding is clean and prep.
Yep.
The 10% with the fire and brimstone, it's the gravy part of it, I think.
Yep, I agree.
Clean and prep, clean and prep, clean and prep.
Yep. You got to do a little work before you get the fun of making the Cadweld connection.
Yep.
So all of the steps that we're going to show you are very important. Clean and dry is always very important. You know, remembering that everything is going to be hot. That exothermic reaction is 4,000 degrees, which is very hot. It's a dry heat, but still hot. So, you know, making sure that you have preheated this mold will ensure that you will make a high quality Cadweld connection later. Another important point that we would like to make is that mixing and matching is really not something we recommend. our molds and our welding material are designed together. So you don't want to use some other manufacturer's welding material in our molds, or vice versa, use our welding material in somebody else's mold. It's important for the quality of the connection, and it's also important to maintain the UL listing. Our Cadweld molds will be UL listed, UL 467. In order to get that UL listing, all of the elements used to make the weld have to be from the same manufacturer. So when the good Dr. Charles Cadweld first started to work with ERICO in 1938 and invented the Cadweld exothermic process as we know it, it became the industry standard. And a lot of folks call any exothermic connection a Cadweld because we are just so well known. So it's always very important that for it to be a Cadweld, you have to use all nVent ERICO Cadweld products. So at the end of this training session, a little important piece of business, you will receive a card that says you are officially trained and a hard hat sticker if you should desire one. This is good for 2 years to prove that you have been trained by a factory representative.
And that'd be us.
Yes. So an important point is that all the information that we need to know about what's inside of this box is written on it. And our part numbering system, as Mike will explain here shortly, tells us everything we need to know about this mold. So if we're having issues later on, we have to make sure that we get this mold part number and make sure that this mold matches the elements that are being welded. So there's the important UL notification and an image of the connection that we're going to start with. Start us on our merry way, Michael.
Okay, I'm going to take the mold out of the box. Again, all the information is on the label on the box as far as the mold family, the price key, and what we're welding. When I open up the box, remove the packing, and what are these?
I don't know, Mike. What could that be?
I don't know. There's verbiage on it. It says IPB. Basically on the front page, we have safety in welding procedure, and everything you need to do to actually make that particular weld. On the back page of it, there's a pictorial of the connection we're going to make. And again, this is a GR connection, so I find the GR on here, and it shows you how to position the cable on that particular ground rod.
Especially in this cable to ground rod connection, it mentions something that we'll show you later on when we're making the connection about supporting the ground rod, the mold on the ground rod when we make the connection. Also included in the instructions is a pictorial set of instructions. So if you don't want to read all of that long verbiage, then here is set out in some very nice pictorial evidence all of the things that I need to do to make a Cadweld connection.
And it's bilingual.
It is. There are many languages here that talk about the welding material with a primary focus on it being hot.
Hot.
Yes.
Yes.
Same thing for the mold. We are telling you that when you start making these connections, everything's going to be hot. So we were kidding about that earlier.
Yep.
So having these instructions is very, very important, especially if things go a little awry later on.
Right. Usually people read these after they make a bad connection, and they'll look and say, whoa, what did I do wrong?
And usually they have to go try to figure out where they threw them.
Right, where they threw them, right.
So we'll keep it here because we may have to refer to this later.
Yeah. And with this application, it's a GR connection, and on the back page of that, it's going to show you a picture of a GR connection. It shows you how to position the rod on the cable on the rod, and basically that's all you do. It's very quick pictorial how to set that up. Okay, as you notice, I'm going to take my mold out of my box, and I'm not using gloves because it's out of the box and it's not hot. We did redo the box to keep the mold from breaking. So the first thing I want to do is, when I open it up, is take a look at the mold, make sure there's no cracks, no divots, nothing that's broken. Very important. What's this for, George?
Isn't that the handle clamp, Mike?
Some people do use it.
Yeah, so this little clip is just intended to keep the two halves of the mold together in the box. box
or shipping,
or on a shelf. It's really not intended to be used to make the connection. It really won't keep the mold closed. I can move this thing around, and that's bad. The welding material is as liquid as water, and if it can find a way out of the mold, it will. So this, ladies and gentlemen, is a handle clamp.
Yes, this is our L160 handle clamp. Before I get into these, on the mold here, again, it gives the instruction print, IPB, gives the mold part number, what we're welding, and the wall material. Very important to match the wall material to the mold. So if it says use 90, you're going to use a 90.
Yeah, the welding material size isn't a suggestion. Our engineers, people like Mike, have designed these molds thermodynamically and based on the yield of our welding material to use a specific amount. It is not something that you can just kind of create on the fly out in the field. I'll show them the inside of the mold, and we'll talk about the different parts.
Okay, this happens to be a vertical split mold. And basically the parts of a mold, you have your crucible, your disc seat, which is used in blue tube, which we'll talk about later, your tap hole, slide cavity, your main cavity, and your mold seal area. No matter what kind of mold you get, it's always going to have these parts of a mold. The pins basically line the mold up and keep the mold together. When I'm placing the L160 on the mold, basically I'm looking at this configuration where I'm flipping these thumb screws out, and this is adjustable. So if I take this pin out and rotate the screw counterclockwise or clockwise, it'll either loosen or tighten the easy handle. I take this opposite the mold again. On this, you have the hole on either side of the top of the mold. This slides right in, drops in, and all this does is keep the mold on the handle.
And the L160 works for vertically split molds like this, or for horizontally split molds. You just change the orientation of the thumb screws so that they would both be on the same side of the mold and on the handle clamp.
So when I lock this mold, you're going to hear a nice little pass center toggle locking action. Doesn't have to be over tightened. So when I put the L160 on it, I can look and see the split all the way around the mold is sealed. Very important.
Yep. And there's no way that just putting the cable in or slipping the rod onto the mold is going to force the mold open. As long as I have the handle clamp on it with this nifty little device, that will not be the case. So a lot of folks will ask, why graphite? Why are the molds made out of graphite? Well, graphite has a lot of wonderful features. It's very durable. It's easy to machine. It can withstand that spike of when we preheat it, being at 250 degrees or so, and going up to 4,000 degrees without any change or cracking or any of that kind of stuff. So it has a lot of virtues. Probably the main reason why I think the good doctor decided to use graphite was from his experience in metallurgy and foundries, and knowing that metal doesn't stick to graphite. So that's important for us now that we're going to make this connection. Every one of these molds is designed to do a specific connection. Within reason, we can do some variability. We can use sleeves to adapt to a smaller size cable, but pretty much these molds have a mission, and it's important that the elements that we're going to use are the elements that this mold is designed for. So the other important thing to consider is the nature of graphite. Graphite is hygroscopic. That means it is sucking moisture out of the air from the day. It's a big giant block of graphite that this mold is cut down into smaller bits, and the mold is made out of it. And it's very, very important that before we make our first connection, we drive that moisture out of the block. So here's a nifty tool, propane torch with our T111 torch head. This allows me to kind of have one hand operation of the torch. I don't need to have anything to start it. just has this neat little trigger that starts the flame. Were you ready to go to that step?
Yeah. Okay. What I'm going to do is open the mold up. I like to dry the mold from the inside out. I know because it's sunny, you're not really seeing the flame on the torch, but it is getting warm.
Yeah, a lot of times when you do the outside of the block, you can actually see the moisture being driven out of it. So after I make a few connections, Mike, do I have to keep doing this?
No, you do not. Basically, if the mold's hot and it's running hot, you don't have to keep drying it out. But if you go to lunch and it's more than a couple hours, then you want to do it again. It only takes a couple seconds to preheat it. It's better to preheat it than to get a bad connection.
Yep. In the summertime, like here in Ohio, it's very humid. That mold will start drawing moisture back into it pretty quickly. So if you're gone for 15 or 20 minutes, always good to take the torch and dry the moisture it's absorbed out of it. We've learned the hard way about doing that after several years of summertime here at University.
Yes.
So it's important to note that all of our Cadweld molds will use either Cadweld Plus or blue tube. The molds are ambidextrous. I don't have to have a separate set of molds for Plus and a separate set of molds for blue tube. So that, I think, was one of our genius moves when we came up with Cadweld Plus.
Okay, this is the part where it does get hot.
Yes. All right, so there is our mold pre-weld prep. We're gonna now get ready to actually make this connection. So we're going to drive a 5/8 ground rod, clean up the end of it, clean up our cable, make our first connection.
Let the fun begin.
Yeehaw! All right, so now we are on to the next phase of our training where we're actually going to start making connections. So the focus of our connections will be on some of the main type of Cadwelds that would be used to build a grounding grid. So at the very start of any grounding grid, we have ground rods driven into the ground, and we are going to join those with cables typically to make a ground ring. So we've driven 3 ground rods into the soil here today so that we can do a GR, a GT, and a GY connection. Those are 3 of the main connections for cable to ground rod. So a little bit of business along the way. When we drove these rods, we made sure that we used a drive sleeve. We did it the old-fashioned way with a big old hammer, and we used either the B13716, which is a piece of hardened steel, or we have this nice little inexpensive tool, the EDS 5/8.
Why do I need to use those?
Well, Mikey, good thing that you ask. It's very important that when we drive these rods, we don't deform the top of the ground rod. That's important no matter whether we're making an exothermic connection, where it's really important for us to have the top of the rod in good shape. But even if you were going to do something as simple as put an acorn clamp on this rod, if you have mushroomed that top of that rod, you're never going to be able to get even a mechanical connector on it. So it's very important that you use something to protect the top of the rod when you're driving it. Another thing that we had mentioned earlier when we were talking about our instruction print is for the cable to ground rod molds, we suggest using something to help the mold be supported on the rod while we're making the connection. When we set this mold up, you'll see that it's the wire that's supporting all the way to the mold, the welding material, and the handle clamp. When the welding material comes in and vaporizes that, there goes the support. So you can either use a pair of locking pliers that almost everybody would have in their toolkit, or we have this nice little tool that is nice one-handed operation, the B399P. So this allows me to very simply put this on the rod without having to do a whole bunch of fooling around like I'd have to do with the locking pliers. So while we're doing advertisements, this is the T315A toolkit. A lot of the tools that we're going to be using here, the pliers, the brushes, they are included in this kit. It's a very worthwhile thing to have for making your Cadweld connections. So there you go. There's a lot of business out of the way, and I think now we can get ready to make our GR connection. What do you think, Mikey?
Okay, you want to show this?
So yes, so here we have the new impulse control unit. This comes with a 6-foot lead, or there's an optional 15-foot lead. The device that we're using today is using the DeWalt version of the rechargeable battery pack. You can use this or a Milwaukee battery pack or good old AA batteries. So big improvement over the old Plus control unit. You have countdown for the reaction sequence, you have battery life indicator, and for safety we now have a trigger guard. You can't just inadvertently press the trigger to start the exothermic process. You have to flip up the guard and press the button, and then you can watch the countdown start so that you'll know when you're going to have your reaction. So the very first connection that we're going to do is the GR connection that we warmed up. And we've already done our pre-weld prep.
Yes, we have.
Take her away, Mikey.
Okay. First thing I want to do is take our T313 card cloth brush, and I'm going to wire brush the top of the rod. You may ask, why am I doing that? Because you want to get all the residue, rust, mill scale off the top of the rod where we're actually making the connection. Again, like I said in the first part of the video, 90% of CAD welding is prep.
There could be oil on the end of the rod. In real life installations in the field, there will be mud and water and all kinds of things. So we always make sure that we use the torch to dry the conductor and dry the top of the rod just to be safe.
Yes.
I'll go get the torch.
Okay, and the cable. And this is a little bit easier because it is short. Usually when you're making connections on a job site, the cable's very long, very difficult. But it's very important to get everything clean and prepped.
Teamwork makes the dream work.
Yep. Going to preheat my cable. Again, per the instructions, the cable is going to sit right about on the center line or an 1/8 inch back. So when the mold's put on the ground rod, it's open a little bit. I'm going to slide this in and lock the mold. Okay, once that's locked, I bring my clamp up, and all that does is keep it from falling when the wall material melts the cable. Next, we're going to take our 90 wall material plus cup. Thank you, sir. We're going to place our grip in the igniter and close the cover. Once that's done, I'm going to press it and you're going to see the light light up. Firing. Beautiful. I'll remove that. Put this aside.
So usually when we're doing this live, we tell folks to flip open the cover and watch the sun go down. Right now there's a very bright orange glow as that welding material that was just a few seconds ago that was granular material turned into superheated copper, went through the parts of the mold that we talked about earlier, went into the weld zone, and has now made that wonderful thing that a Cadweld connection is by fusing conductor and ground rod together forever. All the elements are now one fused homogeneous mass. Let's see what our weld looks like, Michael.
Let's do that.
Oh, that's pretty.
That
you do good work.
Cadweld pretty.
That is.
Wow.
That's jewelry, man.
Good job, George.
Good job. Very nice. Okay, so our next connection will be the GT connection, where we bring the cable across the top of the rod. This is what we use to join rod to rod to rod to make the ring. We'll be right back. The next connection that we're going to do is the GT connection, where we go across the top of the ground rod, so we're literally making that letter T with the conductor. So here's where you can see how important it is to support the mold while we're making the connection, because as we were discussing earlier, all of the weight of the components, the mold and the welding material and the handle clamp, are resting right here. And if we section this connection after we make it, you'd see the conductor right here is fused to the welding material and the ground rod. So supporting the mold with some kind of locking device is very important. So we've already done all of our pre-weld prep. We've cleaned and dried the cable on the top of the rod, and we're ready to make a GT connection.
And preheated the mold.
Yep.
So what we're going to do is slide the cable into the mold and lock it and slide it right down and then lock it. You can see it stops at a certain point. George positioned our clamp so it holds the mold. Ready to Cadweld.
Got our 115 right there.
Got the mold tag, 115 on the plus cup, ready to weld.
There, sir.
We take this, place this in here like this, drop it into the mold, close the cover. On the cover there's two slots. You could either have it going this way or this way, but the igniter has to come out one of the two slot holes in the cover.
And the impulse has a nice little viewing window so you know when the strip is fully seated. So, here we go.
The weld is made.
So the next connection that we're going to do, and the last in our cable to ground rod series, is the GY connection. So the difference between the GY connection and the GT and the GR is that we are going to make the connection on the body of the rod. And we can make this connection anywhere on the body of the rod. So this would allow me to bring several conductors to the rod. Another nifty thing is very often on a drawing, there will be an X to the top of a ground rod, especially in substations where they're building a large grid. So using this mold along with the GT, I can accomplish that task of making that X to the top of the rod, doing it with two simple connections, and using molds that would have future life on the site that I'm working on and at other job sites in the future. So this connection will be made to the body of the rod, and we're going to do a little curve ball here, and that we are going to do the blue tube Cadweld instead of Cadweld Plus. So we've already done all of our pre-weld prep. Cable's clean, rod's clean,
Mold's hot.
mold's hot, we're ready to rock.
Okay. I'm going to place this on the ground rod and the cable goes through the mold. Lock it.
Okay. Spin her around so we're making that
Nice X.
There you go.
All right.
Your disc, sir. So the difference with blue tube compared to Cadweld Plus is we're using a disc. So the disc goes into that machined part of the crucible, and it's going to act as a valve. It's going to hold all of our welding material till it's completely molten. It will burn through the disc and go into the weld zone and weld the 4-aught onto this ground rod forever. Kind of important to note that the disc and the cup are made out of the same material, tin steel.
Yep. I'm placing the disc in the crucible, making sure I'm covering the tap hole, and we're ready to go.
So we open up the blue tube, pour in all the welding material. The starting material, it's probably hard to see on camera, but it's settled into the bottom of the tube. It's vibrated in. So we have to tap it, squeeze it to get the starting material to be able to be removed. We put some down with the welding material. We close the cover, put the rest of the starting material on the cover. So we use a different tool for this application. Instead of the Plus control unit, we're going to use the T320 flint igniter. Would you do the honor, sir?
I would be happy to. I take my flint igniter and place it by the starting material in one spark. The weld is done.
And here you see that X to a ground rod. So the next phase of building our ground grid will be cable-to-cable connections. So these are the types of connections that are either going to be used to extend cable or to make connections to the grid to form pigtails that will bring leads into ground structures. So that happens in all kinds of commercial and industrial facilities, very, very common at substations. Later on we'll show an X mold that is really commonly used in substations, but this connection that we're going to make now is the TA connection. So this mold is probably one of the highest seller, most popular molds that we offer, and it does that job of making a connection to a ground grid with a pigtail cable perfectly. So as you can see, it actually makes a T of the cable, and what we're going to use here is our friend. This is the B265 cable clamp. We can use this in all kinds of applications to help keep cables aligned, keep them in place. You know, Mike and I very often will ask folks to send us images of connections that they're having issues with, and very often it's very evident that the cables have moved. They've put the cables in the mold, they've done other things, and then when the operator goes to make the connection, the cable is not in place, and so now I get this low fill kind of effect. So using this B265 clamp can be used for the GT connection, can be used for this TA connection, can be used for straight splices, a whole host of different connection types. And this kind of tool can help straighten out the conductor, so I'm not trying to make my poor graphite mold do that work.
Actually acts as like a third hand. It's just a helper.
Yep, very good point.
Yes.
It's like having an extra person on the job site for you. So just to be a little bit different here, we have a piece of 37 strand 4-aught and a piece of 7 strand 4-aught, just to show you that our molds are for all 4-aught cables from 7 through 37 strand.
Yep.
And we're going to make the TA connection using the B265 clamp.
And some people ask, can I weld a run together? So realistically, yes. If I clamp everything together and these two cables are touching and the TA, you can make that work. It'll splice the run cable and the tap cable.
And if you use this tool, you're actually going to get that gap in the perfect place.
Yes. Okay, now that I have everything set up, what I'm going to do is take my mold, and as you can see, everything was preheated, the mold's hot, the cable's prepped, ready to go. This is a horizontal split mold, where the other molds we're using were vertical. It's a little bit different because the crucible top section is solid. We'll talk about that in a minute. So right now we're going to make our weld.
So for this kind of mold, it is very, very critical that you do that thorough preheating to make sure that you've driven all the moisture out of this block. If you don't, that moisture that's in this block will go into the connection and increase the volume. And you can fill welding material all the way up into the top part of the crucible here to where we'll never get this mold off the finish weld.
Very important. So all I'm doing is placing my whole assembly into the mold, like that, and locking it together.
Oh, that just makes life so simple.
And what I'm going to do is I'm going to close the cover, and I'm going to check all around the perimeter of my split to make sure the mold is actually seated together. Once I'm assured that the mold's closed properly, I'm going to go ahead and make the weld. In this application, it takes a 150 weld material. Like this.
We're back to our 150 plus.
Yep. And our control unit. I place that on. And ready?
Ready.
Okay.
Fire in the hole. Another chance to see, oh, we talk about the sun going down. That superheated copper metal is starting to chill off. And once that glow lessens, we can open up our mold and take a look at our finished weld. Having this clamp made that quite a bit easier, didn't it, Mike?
Oh, much. It's like having a third person on the job.
Oh, pretty.
Ooh, nice.
Pretty.
Good job.
TAC 2Q2Q.
Okay, to clean the mold.
Yeah, cleaning this type of mold is very important.
What I'm going to do is open the mold up and turn it, and I should just be able to knock everything right out of the mold. The cup falls out. I take my brush.
And make sure you use this brush, not this brush.
Anything with wire will destroy your mold.
Yes.
It's got to be a natural bristle brush.
This is to clean cable. This is to clean a mold.
So what I'm going to do is take my brush, just wipe the cavities out. It doesn't have to be perfect. Get the residue out of the crucible and the cover. Like I say, you don't have to spend a lot of time on it.
How about the tap hole, Mike?
The tap hole, again, when I pushed it out from the back, I made sure everything was all the way through. I should be able to put my cleaning tool all the way through the mold to make sure that tap hole's not restricted by slag.
And sometimes there can be actually a thin layer of slag that builds up in the tap hole,
Yes.
and it starts to reduce the diameter, so it's always a good thing to give it a good visual
Right.
check.
You want to look, open it up, take a look, make sure there's nothing in the crucible and nothing in the weld cavity.
Excellent.
Super.
Let's do a straight splice.
I think that's a good idea.
Okay. Our next connection is a straight splice, in this case SSC2Q. And here once again you see we're employing our B265 clamp. Another good example of how easy it will make having the splice right in the dead center of the weld zone where we need it to be. trying to do that without a clamp like this is a lot of guesswork. So this is a pretty common example of the connection because I'm extending cable to complete my grid or to lengthen the lead that's going to ground the structure. So the SSC2Q will close around the gap here in the conductors, and we will fuse them together to make it like a solid 4/0 cable.
Yep. All I'm going to do is take my mold with my L160, I center it onto the cable, clamp it, and we're good to go. One other thing I'd like to talk about is our mold sealer. A lot of time when a mold is used for a long time, that you may get a little chipping in here. If you take the mold sealer, T403 I believe, and pack it around the conductor, I'm only going to do the one side just to show it, but it'll actually seal up any gaps, especially on a 4/7 strand. If the mold's hot, a lot of time you get that weeping and you'll get a couple drips coming out. So this will stop that.
A lot of times it'll happen with brand new 7-strand cable.
Oh yeah, you'll probably see it a little bit on this side here. Our 90. Oh yeah, there you go. There you go.
Okay.
Okay. Nice thing about the mold sealer, it'll get hot and it'll sort of harden up. Once your connection's made, just tap it off, it'll break right off.
So we've waited our 15 seconds or so.
Beautiful.
Now that is a beautiful connection.
Nice. Restaurant quality.
Yes, sir. Top shelf restaurant quality. Our next connection is the PT connection. In this case, the mold is a PTC 2Q 2Q. If you look at the way the mold works, you see the cables are parallel to each other, one above the other, going through the mold. This mold represents probably the most versatile connection type that we offer. If I'm willing to be clever with the conductors as I'm making this connection, I can make the PT connection where they're one above the other. I can offset them and make a straight splice. I can take the top cable and bend it to make a TA connection, or I can bend the top cable and the bottom cable in opposite directions and have an X. So if you're looking for a mold that does a whole bunch of things in having one block, the PT mold is an answer to that need. So we've already done all of our pre-weld prep. The mold's warm, the cables are clean, and we are going to get ready to make this connection. So here we are moving up to 200 grams of welding material. What we've been doing so far have been 90, 115, 150. This is the highest welding material that we've used in all the connections that we've made so far.
Basically, I'm going to take my cables, put them in the mold, lock the mold together, making sure that my mold's sealed, there's no gaps in the split, and we should be ready to weld.
So we're making this connection here with these short sections of cable. In real life in the field, if you're involved in a training session or doing a training session where the cables are very long, it takes a little bit more of some finesse to get the cables in the mold, but the glorious thing about this mold is once you get them aligned and you close it, you're good to go. So we'll drop in our plus cup. After you, my good man.
Okay. Okay.
Alrighty. Flip up the toggle, press the button on the impulse.
Beautiful.
Let the sun go down a little bit before we open up our mold, check our connection. See, on a nice hot day like this, you don't notice the joy that you can get from a hot graphite block like you can in the wintertime.
Yep, in the wintertime it's a little...
a lot of friends in the wintertime,
exactly.
not so many in the summer. So,
beautiful connection.
nice gold color.
Yep.
And Mike and I were talking earlier about a lot of times when folks are having issues with connections, we ask them to send us pictures. And what we always look for is evidence that they've cleaned the cable, evidence that the mold is for the right size conductors that they've put in it. So as we showed you earlier, you could see the score marks in the conductor to prove that we did our pre-weld cable cleaning and drying. So once again, we have a vertically split mold that we can just clean out with the T394, put it away, and we can get ready for our next connection, which is the XB, the lapped X of 4/0 conductors, very common in substation ground grids. The last connection in our series of cable-to-cable connections is the XB connection. So this, the XB connection, is what we would call a lapped connection of the cables, so they are in different planes. We also make the XA version where I would have to cut one of the cables and butt it against the uncut cable. So for folks that are building ground grids and substations, they really like this idea of not having to cut the cables and being able to build those big 4-foot square grids of conductor using a mold like this.
Much easier.
Yep, very much easier. There have been several iterations of the XB connection. The original XBM, which was a mold with a frame, which was kind of difficult to use because the frame was kind of finicky. Then we did the XBQ type mold, which is horizontally split, 2-piece mold. So just like the TA mold that we did, the top part of the mold was solid. So miss your pre-weld mold prep steps there, and you have a lot of difficulty. So product management and engineering came up with a really good idea of let's take the functionality of the old XBM mold, which was vertically and horizontally split, and create a special handle clamp to make this mold work in the function of the XBM, but way easier to use and close. So this is the this is the L163 mold that's used with these X-type connections, the L163 handle clamp. So we will make this connection and you'll see just how wonderful a tool this is. Michael?
Okay.
Your conductor.
Okay. First step, I'm placing my cable in the top of the mold and securing the mold top half like that, bottom half and bottom half, and locking it together. And we're ready to go.
I wish we had the time to show you the XBM mold. That took a couple of people to operate successfully, and a lot of adjustment on the toggles that close the top part of the mold. So this was a breeze compared to that. So here we're using 250 grams of welding material. It's kind of what we were talking about earlier, the engineered system that a Cadweld connection is. As the orientation of the cables change and the size of the cables change, the welding material goes up.
Okay.
This is a real Cadweld here, buddy.
Cadweld. We'll wait for it to cool a little bit.
So now we're going to reverse the process that we did earlier. We'll open up the bottom part of the mold and then open up the top part of the mold. I think she's done?
I think we're good.
All right. Okay. There you go. Thousands of these in substations all over the planet. All right, that was cable to cable.
All right.
What do you want to do next? Cable to Busbar?
Cable to Busbar would be good.
Cable to Busbar it is.
All right, sweet. See you then.
So the next connection that we're going to make is going to be a connection to a copper object. So ground bar, earth bar, copper strip, whenever we make connections to anything that is copper, we need to do our connection in such a way that we will overcome the copper's natural tendency to act like a heat sink. So we can't weld to the flat face of the copper object. We try to weld to the edge of it. So in doing that, we're attacking a much smaller cross-sectional area of this copper object, and so certainly much more likely to get some melt here at the edge than we would on the flat face. So this would apply to an equipment ground bar like this, an earth bar, a copper strip. Very often we're going to be making these connections on the edge of the copper object so that we can get some good melt. So our example here today is an equipment ground bar. So this would be inside of the structure. We just built our ground grid around, and there would be a pigtail that would be attached to that grid that we built using the cable to cable molds that we just used, that would come into the building and would attach to this ground bar. So engineers very often prefer this because this gives me an irreversible connection to this ground bar so that I can lug up conductors and ground equipment inside of my building and attach them to this ground bar. And now they are as firmly fixed to the ground grid as if I ran a cable all the way out to it. So this LJ connection is the most common connection that we offer for these kinds of applications, especially for grounding or earth bars. To make the connection with the bar in this kind of position is much easier than trying to do it with the bar in situ, as engineers say, mounted on the wall. There's a lot of worry then about clearance and gravity trying to pull my welding material away from where we need it. So Mike has a good point to make about the way the LJ mold functions.
The way this mold is designed, basically you end up with a place for the bar, you have your weld cavity, and for your cable. The important part when this is clamped up, this has to fit against the bar. If it's tilted a little bit one way or the other way, it will leak. So it's very important to have this pressed up against the bar and tight.
And when we say leak, we mean leak. If the mold is not properly positioned up against the bar, a lot of welding material is going to escape. So a lot of bad things there. I'm probably going to damage the bar, I'm going to burn up the conductor, and nobody's usually very happy with that.
Bad things happen.
Yeah, so as you can see, we've done a little extra love here on this copper bar in order to make sure that we've got it clean. Very often copper strip or bar will look squeaky clean, but very often there's oil or kind of that patina on it. So what we did was we used the wire brush, the file, and even a little bit of time with the rasp. These tool marks will help with the adhesion by having smaller cross-sectional areas that we can wash away to make our adhesion of this exothermic connection to this copper bar the best it can be. So we'll set this up, we'll make the weld. And checking that alignment after you put the mold up against the bar before you make the connection is critical. voice of experience there.
Yes. Okay, if you want to slide the cable in, and the cable is going to butt to the bar.
Yep, push it until it stops up against the edge of the bar. You got gap on this side, Mike.
Yep. And the important part to make sure everything's seated. So I'm going to push on both halves of the bar to make sure this mold is seated properly. Once I know it's seated, we're good to go.
So this mold can do bars or strips 1.5 inches and wider. So as long as it's 1.5 inches, and I don't know what that is metrically, I'm thinking that's about, gosh, 35 millimeters, and up, I think. So 1.5 inches and wider, meaning it could be 4 inches, it could be 4 feet. It could be a big ground plate, it doesn't matter. This is also the kind of mold that would be used on a ground plate electrode to make a permanent earth connection to it.
Place that right in like that. Close it. I'm going to double check it one more time. And we're ready to go.
The old triple check.
Triple check.
That's a good sign.
Yeah, it's a good sign.
We're not putting out any fires.
No, that's a good thing.
It's always a good thing.
Double checking is good, triple checking is better.
Triple check is even better. It's like measure once, cut twice.
Yeah.
No, wait.
Yeah.
Measure twice, cut once? How's that go?
Either one. Either one.
You know. Give it another second or two.
Yeah. I think we're good.
Ready to see your handiwork, Mr. Spicola?
All right, I'm ready.
Nice.
Beautiful connection.
Well, that was exciting.
That was fun. I enjoyed that.
Me too.
Nothing better than Cadweld on a hot day.
Nope. Nope. Next.
Next.
Cable to steel surface.
Yes. Beautiful.
The next series of connections that we're going to do are cable to a steel surface. So what we have here is our little rig that we've set up. This nice piece of galvanized steel is a stand-in for a steel beam or some structure in a building. Could be a very substantial I-beam, could be part of a structure in a substation, but we are going to make a VB connection to this steel surface where the cable will go down off of the surface parallel to it. So a great kind of connection to use in a place where I don't want a trip hazard. So both the VB and the VS mold will come with this nice little template. So the nifty thing about this template is it tells me this is the area that I have to clean. And if I use the template to give me some marks for my mold, I know where my mold is supposed to go. So this is the area that I have to clean. A lot of folks, when they send us pictures and they're having problems making connections to steel, they will clean a very large area. And that is not necessary. All I have to do is the weld zone. And it's very important to clean the steel with something that isn't going to leave anything behind. This is a nice electroplated galvanized steel plate, but I still want to clean it to bright metal right where I'm going to be making my weld. And it's very important to do that with something that doesn't leave anything behind. Most grinding wheels are made with resin, and that resin allows them to spin very fast and be very durable and very quickly bring a surface to bright metal. But what they tend to do is deposit some of that resin that holds them together onto the steel surface. And Mike and I can tell you, once that resin is there, it's almost impossible to get rid of it. And even my 4,000 degree welding material may not necessarily penetrate it. So we say use a file or a rasp, or if you're going to use a grinding wheel, then it should be what they call a non-resin bonded wheel. So what we have here is the SBG 100. It's a very nifty battery powered tool, and it's used by our folks in the rail group, so we know that this type of wheel isn't going to deposit anything on the surface. So all I have to do with this tool is clean that very small area. So now I have a nice piece of bright metal. I have some nice tool marks in it that will help with my weld adhesion, and we should be able to make a connection to this plate without any issues. So Mike has some important things to discuss about cable placement in the VB mold.
Right. We already cleaned this side of the mold. We prepped it for the VB connection. The other one's going to be for the VS. When I'm placing my cable in a VB mold, everybody has a tendency to put the cable in, clamp the mold, and push it all the way up to the top. What happens is you usually leave some strands unwelded. So what you want to do is bring it down about 1/8 of an inch, and you can take a peek at it and say, yeah, that's about 1/8 of an inch. And I'm going to spin this way. I'm going to take this and
let's give it a little bit of preheat.
Okay, good idea.
So we're going to preheat the steel. Very often steel, just like our graphite mold, can be hygroscopic. All right, Mikey, clean and dry.
Okay, the mold's hot, steel's hot, everything's good to go. So I'm going to put this on the bottom of my line and clamp it on. Check my cable. And I'm going to look at it, and I'm seeing a little bit of a gap there. So we're going to make a little bit of an adjustment. Is it getting worse or better?
I think we need to come out. There we go.
There we go. I think what was happening is we're on the pivot points of this.
Aha!
Yep.
We did our grinding too low.
Yep. Should have been a little higher, but that's okay.
Oops.
Looks like it's sealed pretty good. Does it look nice and tight to you?
I think we're okay. Let's give it a shot.
Give it a shot. There's a 150.
We'll find out. This is real life.
And then what I'm going to do is, because this is a downward connection, I'm going to put a little mold sealer on the bottom of the cable.
That little note is included in the instructions that come with the mold.
Yep. Okay.
Fire away, Michael.
Here we go. Double check it one more time. Looks good. Fire the hole.
So folks ask about steel thickness for a 150 welding material and 4/0 cable. We want to be in that 3/16 or 1/4 inch thickness for steel. As you can see, we have a pretty substantial heat effect, and we don't want to have burn through. So it's very important that we make sure that the surface that we're going to weld to can accept the kind of welding material and the heat involved with that welding material that we need to make the connection.
Okay.
Nice. So here's another thing that folks ask us about very often, and they'll ask us about testing a Cadweld connection using a hammer. And so, yes, we say you can use the hammer to test your finished Cadweld connection, especially something like this, a VB connection to a steel surface. But we don't suggest you find the biggest person on the job site with the biggest hammer that they could possibly round up on the job site. So if you happen to be working somewhere where there's Thor, who happens to be employed and he's got his big mighty hammer, we don't want that person to check the weld. We want to use a small hammer, and we want to tap the connection with no more force than I would use to start a nail. If something is wrong, if we haven't cleaned the surface properly, or the cable was out of position, or something was wrong, that light tap will yield the result of the cable coming off, or the connection coming off the steel surface. So all we have to do is, that's it. Our work here is done.
You want a nice ring sound when you tap it with the hammer.
Yep. And I think, you know, this is a very good connection. You could probably certainly hit it harder than we did here today, but it's very, very important to remember one thing. This is an electrical connection. It's not meant to hold up the building. It is strictly intended to make a grounding connection to this steel structure. So no more than you would want to go hit a burned crimp or some mechanical bolted connection with a hammer to check its quality or its electrical properties. We certainly don't recommend necessarily beating the connection to death just because it's a weld. So, yep, it's a weld, it's fused, it's a great electrical connection. It's going to never come loose or degrade or increase in resistance over time, but 2 taps. That's it.
Yep.
Let's do a VS.
I'm ready.
Okay. The next connection that we're going to do is a VS connection. So very similar to the VB, the difference being cable here will come off of the surface down towards the ground on a 45-degree angle. So usually these kinds of connections are put in place where there won't be a trip hazard. They'll be either buried or encased in concrete, or it's in an area where there won't be a lot of personnel traffic. With the previous connection, we used our magnetic handle clamp. So a very nifty tool, some very robust earth magnets here. Once they make contact with the steel, they keep the mold and the handle clamp there. For this connection, we're going to use the B134 clamp, which just simply goes on to the L160 handle clamp, and we even pulled out an old school handle clamp here just to show you that you can retrofit any one of the L160s. So this works very much like a C-clamp, and to use this I have to have access to the back of the steel. So if this was a beam, I'd be going to the flange. The magnetic handle clamp would work in the web, in between the flanges. It's very important to point out that either one of these molds would at least have to have the standard L160. So I can use that, but then I have to hold the mold in place and put the cable into the mold and hold the mold and put the welding material in it, and that can be a daunting task. So having something a little bit more expensive like the B396, or something fairly inexpensive if I have access to the back of the steel, or I can use the B134, certainly makes connections to steel very much easier. So we've already done our prep, we've preheated our mold, and so now we're going to use this C-clamp B134 to hold this mold up against the steel.
So basically what I'm going to do is take my 4/0 open the mold up, slide my 4-aught in, and get it close to the edge of the mold. I'll do it this way. There we go.
Okay.
See, I'll sort of bring it down so it's right flat with the mold.
How are we for
Looks good.
lineup?
Looks good. And all we do is tighten it up.
There you
Doesn't
go.
have to be over tight, just snug, and
Yep.
we're good to go. And you want to take a look at it and make sure there's no gaps in between the steel and the flat side of the mold.
Yeah, this is a very inexpensive addition. Makes this kind of connection a heck of a lot easier to do. Sometimes you almost have to grow a third arm, and that doesn't usually work out very
And
well.
just to show it, I'm going to go ahead and put some mold sealer here.
So while our VB connection required 150 grams of welding material, the VS only needs 115.
Place that in, drop my cup in, close the cover, and we should be good to go.
Fire in the hole!
Fire in a hole.
Same thing, you can see the heat effect side opposite where we're making the weld.
One thing you don't want to do with the mold sealer, you don't want to push it up into the cavity. You just want it right around the cable and where it's touching the mold.
Outside of the weld zone, not
Right.
in the weld zone.
Right.
Nothing organic. That's why it's very important to clean the steel surface, make sure there's no paint, rust, epoxy coatings, galvanization. Any of those kinds of things are going to interfere with our exothermic process. About the only thing I wouldn't have to take off would be tin, and you won't very often find a tinned
You will
piece
not.
of steel.
Okay.
I think we're ready, Michael.
Just open your clamp, and that's it. Beautiful weld.
So, just like with our previous connection, we can give it a light rap with a hammer. That's it.
Good to go.
Good to go. Another quality Cadweld connection.
Good job.
Thank you, sir.
All right.
All right, so now after we've done vertical steel, what do you say we do some horizontal
I
steel?
think that's a wonderful idea.
Let's do it.
Okay.
Well, after doing connections to vertical steel, the next set of connections that we're going to tackle are horizontal steel surfaces. So base of tower plates, base of steel structures, those kinds of things. We're going to do two connections. We're going to do a 4-aught and we're going to do a number 6 solid. So just to kind of show you a disparity in mold size and welding material and the fact that we can weld very small conductors. So the very first mold that we're going to do is the HS.
Basically the HS, we have again our crucible, tap hole, our cavity, and it's weld to vertical steel. Very easy. I'm taking my cable. You could either measure it and mark it halfway to the center. If you want to put a little mark on there. I basically put this in the mold, slide it to my mark. So this way it's halfway to the center of the tap hole.
So just that simple little step can make the person who's making these kind of connections, it can make their job a lot easier. Alrighty. So number 115, we've cleaned off our steel, preheated everything. Okay, we're in.
Gloves, very important.
Yep. So here's an old trick of the trade. In order to make sure we're going to get a good seal, we put a little bit of light pressure down on the handle. Off the slag.
Beautiful.
That is an excellent looking
I like that.
Cadweld
That
connection.
is excellent.
So, as with our other connections, light tap proves that we have made a good solid connection to the steel surface. So our next connection is going to be with an HA mold. So different than the HS solid block. So my pre-weld prep is really critical here.
What's the weld material for that?
45, I believe. Michael,
okay.
Yes, it is a 45 plus.
I'll get one.
In doing small conductors like a number 6 solid, we have to use a sleeve to help this small wire accept the thermal shock of the amount of welding material that we are going to apply to it. So what we usually do is we make sure the conductor is extending out past the end of the sleeve, and then we just take a simple tool like a pair of pliers and crimp the sleeve a bit so that it stays on. Okay, so that it stays on the conductor. So here we have 45 plus. Got the hammer, Michael.
Right here.
Okay, thank you. If you would hold it down again
I'll
while
be happy to.
All right, we want to make sure we're getting a good seal against the steel. It rhymed.
Oh,
Good
right.
seal against the steel. So unlike our nice vertically split HS mold, this mold, being the solid block that it is, I have to lift it up off of the connection, and I want to try to go straight up,
That's pretty.
not rocket. It is rather nice, isn't it?
It is. That's gorgeous.
This kind of connection would be cell tower sites, possibly. A lot of those places will use number 2, but smaller conductors. Let's give it a little tap with the hammer. Thank you, sir.
Okay.
Voila. So, that's horizontal steel surface
Yes, it
in
is.
one fell swoop. So this concludes our Cadweld certification training, the virtual version. We thank you for your time and your attention. We hope that this training session has been helpful to you. We covered a lot of ground today, but we did hit all of the main connections that we commonly do in our ERICO University when we do it live. We hope this inspires you to actually do some hands-on training with the molds that we discussed today. So once again, we thank you for your time. After you actually complete a physical training, you'll get these nifty cards and hard hat stickers. And I think Mike and I earned ours today, finally.
Yeah, I think so, yeah.
Cool, hey. So Michael, I thank you very much for your assistance. It's been wonderful. We thank you again for your time with us, and keep on CAD welding.
Ladies and gentlemen, happy CAD welding.
Amen.